Welcome to Standards, Performance Indicators and Certification module. To build reliable, safe, and high-performing PV installations, we must rely on internationally recognized standards. These standards guide the design, testing, grid integration, and ongoing operation of PV systems. Equally important are performance indicators such as capacity utilization factor and performance ratio, which help assess whether a system is performing as expected. In this module, we explore the standards that govern PV components, grid connectivity, and O&M, and we learn how performance metrics and certification practices ensure that PV systems deliver long-term value to consumers and investors. International standards are developed by global agencies through extensive consultation with researchers, engineers, and industry experts. They ensure that PV systems installed anywhere in the world perform reliably across climates, maintain safety for users and grid engineers, deliver expected energy output, comply with local laws and utility requirements. Standards also minimize technical barriers to trade by creating uniform requirements. This allows components to be manufactured globally, tested once, and deployed anywhere provided they meet national certification rules. Three main international organizations define technical standards for the PV sector. IEEE, International Electrotechnical Commission. Most widely used for PV modules, inverters, and testing protocols. IEEE, Institute of Electrical and Electronics Engineers. Defines grid connectivity and power quality requirements. For example, IEEE 1547. UL, Underwriters Laboratories. Widely used in North America for PV hardware and safety tests. Countries may adopt these directly or modify them for local conditions. Importing components requires compliance with the local standard version. PV modules, inverters, cables, fuses, and protection devices must all comply with component-specific standards. These define testing protocols, performance thresholds, environmental durability, and safety characteristics. Key module standards. IEC 61215, Design Qualification for Crystalline Silicon Modules. IEC 61730, Module Safety Qualification. IEC 6280, 4, Potential Induced Degradation PID Testing. IEC 61853, Performance Testing and Energy Rating. IEC 62716, Ammonia Corrosion Testing. IEC 61701, Salt Mist Corrosion, Inverter Standards. IEC 621091 and 621092, Safety of Power Converters. IEC 61683, Inverter Efficiency / MPPT Testing. IEC 62116/UL1741/IEEE 1547, Anti-Islanding Requirements. IEC 60068, Series, Environmental Testing, Temperature, Shock, Vibration, Humidity. Other key standards. IEC 60269, 6 PV fuses. IEC 62305, Lightning Protection. IEC 6036455, 3 switchgear and protective devices. Cable standards. IEC 60227, IEC 60502, EN 50618. Grid connectivity standards. IEEE 1547, Interconnection of Distributed Resources. IEEE 519, Harmonic Limits. Power quality requirements. IEC 62116, Anti-Islanding Test Procedures. IEC 61000, Electromagnetic Compatibility EMC. These standards define how the inverter must behave when the grid voltage or frequency deviates and how quickly it must disconnect during disturbances. O&M standards ensure that a PV system remains within operating limits throughout its lifetime. They define Periodic inspection procedures, electrical and thermal checks. Methods for performance testing. Documentation and reporting formats. Compliance ensures accurate benchmarking and global comparability. PV system performance is quantified using two major metrics. Performance ratio, PR, measures how efficiently the system converts available solar energy into usable AC energy, corrected for temperature, irradiance, and specific losses. Capacity utilization factor, CUF, measures total annual energy generation relative to the system's maximum possible output. PR calculation, condensed explanation. PR equal actual energy output divided irradiance times hours times module area times efficiency. Temperature-corrected PR includes a temperature correction factor. Factors excluded from PR tests: grid outage losses, irradiance below 250 W per square meter, outage period irradiance, acceptable PR range 75 to 85% depending on site conditions. CUF calculation. CUF equal actual energy output divided installed capacity times 24 times 365. System performance depends on several design and environmental parameters. Tilt and azimuth optimization. Component technology choices. North-south versus east-west orientation. Module degradation profiles. Quality of O&M and cleaning frequency. Environmental exposure heat, dust, moisture accelerates degradation. Good design minimizes losses and ensures long-term reliability. Software tools provide accurate simulations of system behavior. Common tools: PV-SYST, Helioscope, NREL SAM, P50, P75, P90 values. These represent probability-based energy guarantees. P50, expected aggressive annual energy. P90, conservative estimate, exceeded 90% of the time. These metrics help investors understand financial risk and confidence levels. Testing and commissioning ensure that components and the system operate safely and as per standards before grid synchronization. Key commissioning tests: anti-islanding test, IEEE 1547 IEC 62116. Insulation resistance test, earth resistance test, three-point and clamp method. Inverter power quality tests, THD, flicker, DC injection. String testing, voltage, current, insulation. Module tests, visual, electroluminescence, EL. PID stress. Measurement parameters as per IEC 61724. Verification of safety features and PPE compliance. Components must be certified against applicable standards by recognized laboratories. Certificates must match the exact model number of the component, be valid at the time of commissioning, come from accredited labs, reflect the correct bill of materials, BOM. Any change in BOM requires recertification. Solar modules use type test certificates, not per unit certificates. Maintaining documentation ensures complete traceability and compliance. Standards bring uniformity, safety, and reliability to PV systems. Performance indicators like PR and CUF ensure systems operate at expected efficiency. Testing and certification safeguard long-term performance and consumer confidence. By applying these principles, solar PV plants remain safe, efficient, and aligned with global best practices. Thanks for going through and reading. Don't forget to like, share, and subscribe for more solar insights from I-SED Academy. Please go to I-SED Academy platform for detailed learning about solar technologies.